Bonjour, mon ami. Thus ends the French portion of my presentation. That's all I got. So we'll have to go with English after that. I'm really glad you're here. I know it's the middle of the last day. Actually, for those of us from the US, it's actually already a holiday weekend. It's Memorial Day, so I'll be flying back a little late. But I think this will be interesting. I know you'll walk away learning at least a few things you didn't know before. So stick with me for just 30 minutes, and we'll try to make it really worth your while. The topic of the presentation is called machine scale performance. And really, what it's really about is what's the business case for artificial intelligence? Why are we so worked up about it from a business perspective, right? There's a lot of other perspectives, a lot of other dialogues, a lot of other themes we can have, but we're going to focus on the business value of AI and how that's playing out. So machines have been around for a long, long time, right? I mean, Archimedes talked about this idea of simple machines, levers and pulleys 5,000 years ago. The actual word machine is derived from the Greek word mikos, which means to remedy. And we've been remedying sort of problems in our lives from digging holes in the ground to building, houses with stones and wood for a long time. And it's only in the last 150 years that we started to actually electrify, connect, computize, digitize, robotize, cognitize, and very recently autonomize machines, right? This is the current sort of paradigm of where we are, and it's not one or the other. I mean, these are, I use sort of the hexagons to create that sort of looking like a chemical kind of thing to convey the point that these are the building blocks, right? This is the DNA of modern machines, and you really need all of those to achieve, the goals that we want in society. But we're not quite there yet, right? I mean, we're not quite at the stage of fully autonomous machines roaming around all of our streets, but we are definitely moving in that direction. And this evolution, is gaining momentum, partly because of this thing we called artificial intelligence. Now, there's been a lot of talk about maybe swapping out the word A for augmented intelligence or, other versions of that, but it really doesn't matter what you call it, right? What we're talking about is software that's not programmed to execute, but programmed to learn. That's fundamentally the difference here, right? This is a computational emulation of human-like cognitive skills. And I could spend 30 minutes just going into that one sentence, and we're just going to leave it there for now. But the important thing is it's gaining momentum. And it's gaining momentum. I mean, just look on the other side of this curtain, right? I mean, we don't really need any more evidence than the size of this event. And this is just in this one city, right? Across the world, across all industries. And I do have this perspective as the global head of AI. And I've been in 10 or 11 countries since January. I was just in Ireland this past week. I was in Lithuania and Estonia 2 weeks ago. Just around the world, I can tell you unequivocally, without any hesitation, that every sector of the economy, every government that I have met with is aggressively looking at how to take advantage and harness the power of AI. So the momentum is there. Now, much of the focus is on what we can do with it. The use cases, right? How to apply it. But we kind of skip over this really critical question of why. It's almost like everyone just assumes it's going to be a good thing, and they know the value. They just run right into it. And that's because companies have been investing in these capabilities, but they're using a traditional business case. They're using a business case that is anchored to decades of technology investments based on incremental improvements and efficiency and output. This is what we know. I mean, IT departments, executive teams, they understand this model. And so they've been applying that. But is that really the end game? And I'm going to say to you it's not. I'm going to say the world is thinking way too small because people are just in a rush. We're all busy, so we don't take the time to step back. But then, you have people like me that take a step back, and we kind of look at it. We unpack it. We peel the onion. We peek behind the hood, and we say, what's really going on, right? Where's the real value? Now, as companies integrate human workforces with robotic, intelligent, and autonomous machines, they're creating a fundamentally different kind of workforce, a fundamentally different kind of company. And this real end game is what I'll call a new outer boundary of performance. And that outer boundary breaks from our current understanding of three core concepts: value, performance, and competition. Everything you think about, everything you know about what's valuable, what means good performance, what is a high-performing team, and what are we competing on, everything you know is anchored to a very human-scale understanding of the world, which means it's the wrong perspective when you're thinking about AI. So let me break it down a little bit further. So today, performance is measured in what I would call very human terms. So what is that? That means what can people do in a single Earth cycle? Now, I didn't know that I didn't actually know before I showed up today that the guy before me was going to be talking about space exploration and moons. It was actually very convenient because I got a bunch of similar sort of stories woven throughout this. So kind of building on that prior conversation. But here's the thing. What's an Earth cycle? It's a minute. It's an hour. It's a day. It's a week, right? We think in terms of these Earth cycles, and we think in terms of human limits, whether we know it or not. I'm not saying it's a conscious thing, but that's just how we're grown up. So, we might, when we're coming to measure productivity, you might say, how many samples can that geologist review in an hour? How many web pages can a developer, develop in a weekend? Now, that's a function of pizza and Mountain Dew and a bunch of things. That isn't strictly speaking Earth cycles. But how many job applicants can HR review, right? How many patients can a nurse check in a single shift, right? These are the things we think about. So when we start to make improvements, when we make investments, when we think about the value, the performance, and the competitive nature of what we do, we typically think, how long will it take this person, this team, this department to do this task in this period of time? And without realizing it, we have completely set boundaries on the potential value of a workforce that's integrated with artificial intelligence. What we've also done, it's not only biology, there is another element to this, and again, this is another 30-minute conversation, so I can't go too deep, but there's also this notion of what is fair, what is appropriate, what is legal, what is regulated, right? I mean, today is a big day, right? It's the actual kickoff of GDPR. I mean, there's a lot going on in the regulatory world, which is going to put boundaries about what we can do with certain kinds of technology in our lives. Those are things we want. Those are good things. But when it comes to the implementation or the application of AI at work, if you apply arbitrary boundaries based on what you think is possible or fair, forget what's legal and appropriate. That you need to do. But if you're thinking about what's possible, you may completely underscope the potential. So AI brings us to a completely new place. It doesn't just change the potential speed of business, it changes the nature of it. So let me break that down. I know these are really small words. I don't know if everyone can read it, but I'm gonna summarize it for you. So when we go to work, we do fundamentally 6 things. So let's bucket our contributions in 6 ways. 1, we learn and master skills, whatever that is. 2, we execute tasks with a certain level of speed and accuracy, some better than others, right? 3, we learn knowledge, sometimes at home, and we apply it at work, right? We transfer that knowledge from one domain to another. We empathize and we adjust. Now, not every job requires the same level of empathy, but even interacting with colleagues, interacting with customers, interacting with vendors, doesn't matter. You have certain ability to empathize and adjust your behavior. You engage in various natural ways, whether it's through language, through text, through body language, but you engage with people, and that's part of how you do your job. And of course, you're original. Now, not all of us are equally as original as others, but at some point during the day, you may have to write an email, or maybe you have to compose a concept, or develop a presentation, or whatever it is, but you do actually apply some level of original thought. Now, machines are getting a whole lot smarter because of artificial intelligence. And this is something most people don't appreciate unless you study the history of robotics. Up until a few years ago, pretty much every machine ever created was pretty dumb. I mean, and that's not an insult to machines. It's just their very purpose in life was to execute commands. And they did those, sometimes very effectively, but they had no human-like cognitive abilities until fairly recently. Right? Now that we're and there's a lot of them roaming this floor, right? I mean, just walk around. So this is the Softbank Robot now, and then I think he's over there as well. So it's a nifty little guy. It looks like a Christmas gift, but it costs about $10,000, so it's kind of an expensive Christmas gift. But it's packed with functionality. It's very cool. So AI-infused robotics, machines that have these human-like intelligent capabilities, open up whole new possibilities for service models, engagement models, strategies, right? But still, if you don't think about it in the right construct, if you're thinking about it in very human terms, then you're really undercutting the potential of that machine. So here's the good news and the bad news of where we are. This should not ruin your weekend, but it depends on how much you dwell on it. So you got 6 areas where we, on average, are contributing at work. Now, I didn't take a survey. I didn't conduct a scientific poll. This is a thought exercise, but I think I'm pretty spot on. Currently, machines outperform us, can outperform us, let me put it that way, can outperform us in 2 of the 6 areas. We're holding on to 4. They're making headway, particular in the area of empathy and adjustment. This is an area, artificial empathy, emotional intelligence. I know we like to think that we really own that, right? That's a uniquely human skill. Unfortunately, it's also a very learnable skill. It's a very quantifiable skill. So machines have already been well established, if you do the research, they're way better than humans at detecting lying, deception, interpreting moods. I mean, just go down the list. They're actually very, very effective at that. But nonetheless, I'd say we still kind of hold dominion in that area. But when it comes to learning skills and executing in speed and accuracy, the list where machines are able to do that better than us is becoming pretty long. But that's okay, right? The idea is how to leverage that. But let me give you some examples. So as work becomes more automated, regardless of how or why, humans are still very relevant, but human scale metrics are less relevant. So I don't know about you, I've never been able to solve a Rubik's Cube. I'm always pretty impressed when I find someone that can do that. If you could do it in a week, I'm impressed. If you could do it in a day, I'm really impressed. If I hand you a Rubik's Cube and you come back to me in an hour, I kind of think you're probably a freak of some kind, right? I'd be like, well, that's pretty good. If you could do it in a minute, then clearly one of your parents is probably an alien, and then you just need to look at that, okay? But here's a machine that could look at a Rubik's Cube and with computer vision and the mechanical skills of motor-equipped arms, calculating 46 quadrillion possibilities, it could not only think about, but it could literally solve a Rubik's Cube in 0.6 seconds. And you can find this video on YouTube if you don't believe me, right? Its ability to both think and execute with speed and accuracy is far greater than any human could possibly do, right? Because it's not constrained by the limits of biology and Earth cycles. It works in a completely different plane of performance. That's the new outer boundary that we're talking about, right? So let's give you 2 really profound examples from outside the business world. I'm not an astrophysicist. Are there any astrophysicists in the room? Because I always like to ask that, because they're going to call BS on me, whatever. So it's better not to have any here. Okay, but this is a great story. This is one of these things that's should totally freak you out because you somehow didn't catch this story. This is a huge story in the history of the world, but it went by most folks because you're not looking for it, all right? So I'm going to tell you today what it is. So astrophysics is a really complex field. To be an astrophysicist takes thousands of hours of graduate education, field work, you can imagine, right? Multiple degrees often, right? And there's not that many of them in the world, just a few thousand in the world. So there's this celestial anomaly called a gravitational lens. It's a whole Albert Einstein thing, not that important to go into it, but here's the important thing. When we discover these things, it changes our entire view of the universe, and it's very, very important. So we're constantly, as a community, astrophysicists are constantly downloading images from the Hubble telescope and then looking for these gravitational lenses, trying to identify, qualify them, grade them, and they have to agree as a community, like, yep, do you agree, I agree, you agree. It's kind of this big deal. And when they do agree, it impacts the math on a galactic scale. Because it changes the way we look at the universe. It helps identify things. It's a big deal. We haven't found that many. I don't think they've found more than 15 in the last 50 years. But it takes like 3 to 6 months of a team of astrophysicists, collectively, who probably have tens of thousands of hours of training and experience to identify a gravitational lens. Last summer, working with Stanford University, they developed a neural network. And they took those tens of thousands of hours of knowledge and they trained that network up in a single day, 8 hours. That system is able to perform the same function as a team of astrophysicists, and it can do that in 1/3 of a second, which is a little bit faster than solving the Rubik's Cube. So what is the impact? Faster doesn't quite cover it. It has completely and totally revolutionized the field of astrophysics. It has improved and accelerated it 10 million%. So what you may or may not have noticed, but now you should go back and look, is the parade of announcements from the world of astrophysics since last summer. They found the largest black hole ever found. They discovered the 10th planet. They've discovered the furthest star ever found. And this goes on and on and on and on. And that's because we are now doing lifetimes of science in a day. And it is materially impacting that field. The real takeaway, though, is it only took them 8 hours. And that machine can now perform the function of a team of astrophysicists in 1/3 of a second. So just think about that. All right, another example. Now this was a bigger headline. A lot of, you may have heard this one. This one caught a lot of headlines a couple years ago when Google's AlphaGo master program beat the world's leading player of this game called Go. And most of us didn't even know what Go was until we saw this headline. But this was a big deal because this game is way more complex than chess. There are more moves in this game than there are atoms in the universe. So this is not an easy game, and it requires strategy and cunning and deception. I mean, this is not an easy game to beat. And yet, as the headlines were played, it took the world by surprise. But this is a follow-on story to that. So this is not about that. So a year later, again, last year, because this original story happened in 2016. In 2017, the same team that designed the first computer designed version 2, called AlphaGo Zero. AlphaGo Zero beat AlphaGo Master 100-0. It was 100 times better than the first version. But here was the really incredible thing. Going back to my little model of cognitive skills, it learned how to play that game in 4 days. It went from having no knowledge of the game to being 100 times better than the world's best player in 70 hours. And it had no human supervision. It was an unsupervised learning process, which means that it had the basic fundamental rules, and then it taught itself, and then it learned, and then improved upon itself. So what did it do in 4 days? It played thousands of years of games in 4 days. That's hard to calculate. That's non-biological nature, right? I mean, there's no way to calculate that. 1,000 years of games in 4 days. But that's because we're thinking in human scale. We're thinking too small. You have to think bigger. So machine scale performance is measured in orders of magnitude. Does anyone here know what orders of magnitude? Zeros, right? 10 to the first power, the second power, the third power, right? I mean, scientists developed that whole method because when they're looking up at the stars, they're trying to calculate the distance of the universe. You just can't use enough zeros. It just gets kind of messy, takes up the page. So they developed this whole thing, orders of magnitude. Well, this is 7 orders of magnitude, in that one example. 10 million times faster and performs in 1/3 of a second. Thousands of years of knowledge in 4 days. So just keep that in mind. All right, so if AI can accelerate scientific discovery by 7 orders of magnitude, imagine what it could do for your supply chain. Imagine, if it can do this, imagine what it can do here. Because you don't necessarily need 10 million% improvement in every part of your business. I mean, that's not really the goal, right? It's a crazy, extreme example, but it's completely true. So imagine what it can do for financial reconciliation or energy optimization or improving the call center operations. Right? Just go down the list. Think about it in the context of a business that you're running, a business that you're building, or a business that you're buying, and how you could leverage it into that business. Now, what's really great about this show, as I walk around, is you can see almost every industry represented here. There's aerospace and engineering, there's smart buildings, there's hotels. This is a pretty great cross-section of the economy. And that is true of this story as well. Because you don't just see this in the field of science or in gaming. You're seeing this playing out. Robotic shopping cart. Flipping the hamburger is a real thing. Now, I don't know if you need to flip hamburgers 10 million times faster either, right? Sometimes, that level of ambition is not necessary. But even bricklaying, bricks have been laid the same way since the pyramids, more or less. But now robotics are being introduced in a way that improves the speed. Well, it doesn't improve. It takes the speed of building a building up 500%. It's pretty meaningful. So whether it's warehousing, it's food, it's hedge funds, it doesn't matter, right? It's every sector of the economy, everywhere. Now, this is a really big takeaway because now, just take me at my word, right? This is a big impact thing, but you can mess it up. You can do it wrong. You can be excited and enthusiastic, but you can actually apply the wrong approach. So here's the right approach. More is not always more in this context. The relentless pursuit of automation is not the answer. The optimal blend of human-machine capabilities is the answer. And that sounds a little bit consulting-like, it sounds a little bit fancy, but it is the only way to do it right. If you just jam in a lot of AI, in fact, I'll go further than that. The least amount of AI is the right answer. Because artificial intelligence, as interesting, dynamic, and revolutionary as it is, introduces complexity and risk as well. So in any given situation that you're trying to improve a business process or a customer experience or a service innovation, you want to use the least amount of complexity and risk, right? So you want to balance robotics, rules-based automation with human-like cognitive automation, and you want to do it in a way that is also mindful of the risks, the constraints, the impacts to people, the regulations that you're going to have. I mean, all these things. You have to make that optimal blend. Anything short of that is frankly going to lead to a suboptimal result. And I think this, and I really, really appreciate Elon Musk's transparency, because it was really convenient for my presentation today that he said this a few weeks ago. So I'm going to give him all the credit in the world for it, which is, you know, Tesla was really struggling with its manufacturing process the last year, and you know, in his own words, he referred to production hell, and they were behind schedule. And again, this is widely known, right? But what's really amazing, and what I give him credit for, and to really give you context for his statement, is he came out and said, you know, we built this thing we called the Dreadnought, and it's got all these machines and robots. You know, we were pretty excited about it, but this complex network of automated systems didn't quite perform the way we thought. In fact, we're going to pull some of the robots out. Not all of them, of course, but some. We're going to put some more humans back in. What's so brilliant about that honesty and that admission is that is the journey you have to go on, because finding that optimal blend of human machines is not obvious to anybody from day one. There's no formula. It doesn't matter how many times you've put in ERP. It doesn't matter how many times you've rolled out workplace productivity software. This is a fundamentally different problem that you're trying to solve. And what Elon is admitting is that, you know, hey, we went all the way over here, now we're going to come back a little bit over here. But that's the journey. And I don't know how many other companies would be as transparent as he's been, but the truth is you need both. You need humans and machines to achieve this new outer boundary performance. So to kind of come full circle, how we value things, consciously or subconsciously or not, we value them based on what we know. And the mental model we bring to work is based on what we think people can do in an hour, in a day, in a week, right? That's our definition of value. And so when we go to identify what's high performing, what's great performance, whether it's on an individual scale, like, hey, John, great job this week, you really turned that around, you got it on time, or an entire company, you're going to measure it based on these principles of what humans can do in an Earth cycle. And that's going to fundamentally undermine your ability to really grab the potential of what AI can do for your business. So it's not just value and performance, it's also competition. Because if you have a new understanding of value based on this blend, and you have a new definition of performance, this new outer boundary of performance based on humans and machines working together, then you have a new basis for competition. To compete on the basis of this outer boundary performance, leveraging humans, leveraging machines that can scale human-like cognitive abilities beyond natural limits. And again, there are places where humans are way better for any certain business task, and there are situations where machines are way better. You've got to find that right balance, but you have to understand when you bring them together under the right terms, mindful of all the constraints and risks, you achieve a new boundary performance, and that is why, and some of my fellows in the consulting industry have called this an insurmountable advantage, which I think is as good as any other term. You achieve an insurmountable advantage over your competitors, who, if they don't understand this, will be stuck trying to get incremental improvements, incremental value, and you will be in a completely different ballpark, a completely different quadrant of performance, while they're still figuring that out. So that is that's the whole presentation. That's the whole story. I hope that was valuable for you. I hope you learned something, and I thank you very much for your time.